Hello and welcome to MyScience Tutorials. In today's video, I want to talk about the determination of molecular weight from osmotic pressure. Before we begin, if you are new to MyScience Tutorials, make sure you subscribe to the channel and press that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. Now, in our previous tutorial, we did establish the fact that osmotic pressure given to us by pi can be given to us by the Van Holt equation as what pi v is equal to what nRT, where we are saying our pi is the osmotic pressure in atmosphere. So osmotic pressure in atmosphere, or ATM. We are saying our v is the volume of solution in liters, and our n is the mole of solute. Mole of solute. Our r, we are saying, is a constant, and the value of that constant is what? 0.0821 liters atmosphere per Kelvin per mole, where T is what? The absolute temperature in Kelvin. Now, when we want to determine the molecular weight or the molecular mass of the solute present, all we need to do is the mole over here, the mole, we've been using the notation since the beginning of colligative property, W over what? Small m, where we are saying the small w is what? Is the mass of the solute, and the small m is what? The molar mass of the solute. So if we do this substitution into this formula, we get what? Pi v to be equal to what? W over what? M multiplied by RT. So let's try to make m the subject, or the molecular mass the subject. So if we want to do that, we get what? Pi v over here to be equal to what? WRT on what? M. So if we make m the subject, we get what? WRT divided by what? Pi v. So it means when we want to calculate the molar mass of a particular solute, provided we don't know the solute and we only know the mass and we know the osmotic pressure, we can use this formula to calculate what? The molar mass of the solute, and we can be able to see this particular solute based on the molar mass is likely to be what? A particular type of solute based on the molar mass. So with this basic introduction, let's have a look at some few examples. So example number 1, we have a solution of glucose containing 18 grams per liter was observed to have an osmotic pressure of what? 2.39 atmosphere at 23 degrees Celsius. So we have to calculate the molecular weight of glucose. Alright, so we have a solution of glucose containing 18 grams per liter. So it means our mass is the small w is what? 18 grams per liter, means our volume is what? 1000 milliliters, which is what? 1 liter, and our osmotic pressure pi is equal to what? 2.39 atm, and our temperature is what? 23 meanwhile degrees Celsius. So we need to add what? 273 to it to get it in Kelvin, and if we add that, we get what? 296 Kelvin. Right, so now that we have all the parameters that we need, we just need to put the formula for the molecular weight or the molecular mass calculation from the equation what? Pi v is equal to what? nRT. We know that our pi v, our mole, we are saying, is what? The mass, or the molar mass RT. So if we make m the subject over here, we are getting our m to be what? WRT over what? Pi v. Alright, so our m is equal to, our w is 18, our r we said is what? 0.0821. So we have 0.0821 multiplied by the temperature we said is what, 296, divided by our pi, which is the osmotic pressure, is what, 2.39, multiplied by the volume, which is what, per liter, so it is 1. So if we do the computation, we see that our molecular weight is what, 183.02. So therefore it means the molecular weight of glucose is equal to what, 183 approximately. All right, example number 2. A solution of glycol containing 1.821 gram per liter has an osmotic pressure of 0.682 atmosphere of mercury at 10 degrees Celsius. What is the molecular mass of glycol? So just like we did for the first example, we have solution. We have the mass, is small w, is what, 1.821 gram per liter, means the volume is what, 1 liter, and then the osmotic pressure was given to us to be what, 0.682 atm. The temperature is what, 10, so we add what, 273 to it. This will give us what, 283 Kelvin. So we have to calculate the molecular mass of glycol. So straight ahead, we know the molecular mass or the molecular weight will be what, m is equal to what, WRT over what, pi v. So we have our m to be w is what, 1.821, which is the mass of the solute, multiplied by the constant, which we are saying is what, 0.0821, multiplied by the temperature, which we found to be what, 283, divided by the osmotic pressure, which is what, 0.682, multiplied by the volume, which is 1. So it means our molecular mass, okay, of the glycol is what, 62. If we do the computation of all this, we get what, 62.04 gram per mole as the molecular mass of glycol. So thank you so much for watching, and I will see you in the next video. Bye bye.